Physical Science Nobel 2023. What precisely have in Lhuillier, Pierre Agostini, and Ferenc Krauss done in the field of the investigation of electrons? For what reason is this significant? Nobel Prize 2023 victors. The Nobel Prize in Material Science for 2023 has gone to 3 researchers whose work made it simpler to notice electrons, and which has expected applications in the field of diagnosing sicknesses and creating electronic contraptions. And Lhuillier, Pierre Agostini, and Ferenc Krauss have been granted for their trials which have given mankind new apparatuses for investigating the universe of electrons inside iotas and atoms. They have exhibited a method for making very short beats of light that can be utilized to gauge the fast cycles in which electrons move or change energy, said the Nobel Prize's site. What precisely have the researchers done? A molecule, a little unit into which matter can be separated, is made out of a core of protons and neutrons, and electrons that movement around this core. Electrons move so quick that noticing them progressively is incomprehensible. Crafted by Lhuillier, Agostini, and Krauss has carried humankind closer to noticing and concentrating on the development of electrons, by delivering beats of light that last just attoseconds, which is 1 × 10⁻18 of a second. Generally, this can measure up to a high-screen speed camera. On the off chance that a typical camera is utilized to catch a moving train, the picture will be obscured. However, a high-screen speed camera can freeze movement and catch an unmistakable picture of the train. How could they do this? Each of the 3 worked in the field for a really long time. As per the Nobel site, back in 1987, Lhuillier found that when a laser light wave was gone through an honorable gas, it communicated with the iotas, giving a few electrons additional energy that was then produced as light. She kept on dealing with this. In 2001, Pierre Agostini prevailed with regards to delivering and researching a progression of sequential light heartbeats, or blazes of light, in which each heartbeat endured only 250 attoseconds. Simultaneously, Ferenc Krauss was working with one more kind of examination, one that made it conceivable to detach a solitary light heartbeat that endured 650 attoseconds, said the Nobel site. These blazes of light made it conceivable to give pictures of cycles inside particles.